This is a tutorial on the DBIR Attack Graph web app. Before we can understand the web app, we need to understand why attack graphs. When most people think about breaches, we now think about it as a path. Lockheed Martin's cyber kill chain helps us explain the path that attackers take. And so we know that it's not a single point in time. However, we still kind of look at the path as if it's got a discrete start and a discrete end. So the breach starts at some point and it stops at some point, and that's no longer really the case. In reality, breaches cycle. This is a picture of the 2015 DBIR, visualized as an attack graph. So attacks start at the green dot in the lower right. They move through attacker actions, which are the red dots. They move on to the compromised attributes, which are the light blue dots. And finally, they end at the purple dot in the upper left. Now, cycles can bounce back and forth in one of two ways. First, actors can take an action which compromises an attribute. Then they take another action which compromises another attribute, and they bounce back and forth until they get to the attribute they really wanted to compromise. Alternately, attackers may have a successful breach, and they use what they gained in that breach for their next breach, and they use in that breach for the next breach, continuing the cycle of breaches. And there are lots of paths. There are probably more paths in this attack graph for an attacker to take than there are stars in the universe. That's why defense is hard. You stop one attack with one mitigation, and the attacker simply finds another path around your mitigation. So some attack paths are short. In this case, an attacker pushes the denial of service button, it starts a denial of service, and it causes degradation. But what if the attacker doesn't have a denial of service button? He's going to have to work to get there. And so he may have to bait someone into going to his malicious website, which drops a piece of malware, and that gives him command and control and gives him a platform with which he can do that denial of service. And then the result's still the same. He does the denial of services and causes a degradation. However, his attack path to get there was much longer. He had to go back and forth a lot more times. And that's our job as defenders, to make that path as long and hard as possible. That's why we're making one of our R&D tools, the DBIR Attack Graph web app, available to others. The DBIR Attack Graph web app lets you plan to mitigate all paths an attacker can take, not just a single step and a single one. The first thing you want to do when you use the web app is select what worries you so that your analysis is only based on the breaches which apply to you. You can choose your industry, or you can choose the pattern that defines the attacks your organization expects to experience. And notice when you do choose it, the graph on the right changes to represent what you selected. Once you have picked what worries you, you can pick the attributes you want to protect. And so if you're a web services company, maybe you want to pick the loss of availability of your website. Or a medical company may want to pick the personal, financial, medical records of its patients to protect. Or an IT company may want to protect its internal company secrets. And so let's say we're worried about PCI type issues, and so we want to protect the confidentiality of our payment data. And so we select that, and we see it changes the graph over here. So now only the payment node is connected to the end node. All the rest are grayed out. It also changed the attack paths down here. And so these are only the paths which exist in the worry graph we chose, as well as ones that end in the attributes that we chose. And the value is relative. And so a value of 2 means this is twice as unlikely to happen as a path of 1. Or it could be read twice as hard, takes twice as long, or costs twice as much for the attacker to do this attack. So let's analyze protecting payment information in the crimeware pattern. When we click the analysis button, a lot of complex analysis happens in the graph on the back end, ultimately resulting in a recommendation. In this case, the recommendation is to mitigate RAM scraping malware. Doing so could potentially remove 100% of the attack paths through the graph. If it hadn't removed 100% of the paths, it would tell us how much harder the remaining paths had gotten. Now, in a future update, we'll probably add recommending controls rather than just various enumerations. Even without that, though, you can figure out what kind of controls you need. In this case, you may want to encrypt data in memory or try to prevent the installation of malicious software. So let's take another example. Let's take an espionage example. And you see when we do that, it resets the analysis, it resets the graph, and it resets the paths. And so let's say what we care about is the protection of our internal company information. So we're going to go with classified information, copyrighted information, not really payment anymore, but internal source codes, secrets, and system information. And you can see that that's now what's represented in the graph and in the bars. And so when we analyze that, it comes back with a different recommendation. In this case, it recommends mitigating the hacking use of backdoors and C2. And when we do that, we've eliminated 4.3% of the paths. However, we've made the remaining paths 32% harder. And so we can look at it before and after. And so before, without mitigation, this is what the attack paths look like. There's more of them and they're shorter. And when we look at it with mitigation, there are fewer paths and they're longer, significantly longer, in this case, 32% longer. Hopefully this quick tutorial has been helpful in understanding both why graphs are necessary to plan mitigations, as well as how to understand the use of the Attack Graph web app. If you need more information, you can reach me at GDBASSETT on Twitter, or the entire DBIR team at DBIR@Verizon.com. Thank you and have a great day.